next we move on to exercise 2. So for this exercise 2, you have a plane wave propagating through a medium, okay, with the epsilon 8, okay, and the mu r is equals to 2, and the equation for the electric field is represented by this. So you have to find beta, okay, beta, the loss tangent, the wave impedance, the wave velocity, and also equation for the magnetic field. Okay, so we can look at the solutions. So first of all, we jot down the information from the questions, given this one, and also this. Okay, so we have to find the beta. Okay, according to the questions, this alpha or the attenuation constant is 1/3, and we know that for this medium it is a lossy dielectric. Okay, so for this lossy dielectric, the attenuation constant can be calculated by using these equations. So we check again all the variable here. Okay, this one given by the questions. Okay, so for the mu has been given, epsilon also has been given, but sigma is not given, so meaning that we cannot calculate this term. Anyway, we have the other method. Okay, so here I assume a, just a variable, okay, which is this one. Okay, it's represented by this one. So here I simplified my equations, okay, given by the questions. Okay, this one is the alpha, okay, and all the things I insert it, but here I replace it with a. So based on these calculations, I get my a equals to 1.125. So the value of the mu naught and also epsilon, you can get it from your calculator. It has been saved as a constant in your calculator. You can check it out. Okay, so after I get this a, okay, I will use it in the equation for my beta. Okay, so for equation of beta, this one will be changed to plus. So here you see a plus. So here I plug in, okay, same thing. So here my beta is equivalent to 1.375. So the second one is loss tangent. Okay, so this is a symbol of loss tangent. You can calculate it based on the angle of the intrinsic impedance or these equations. Okay, so just now, okay, we have calculated the A is equivalent to 1.125. Okay, but it is the whole thing. But here I only want this thing. Okay, so I simplify it and move around, square it, and then I can get 0.5154 as my loss tangent. And next one is the wave impedance. Okay, I can calculate by using this equation for wave impedance. Okay, so based on the calculation that we got just now, okay, this is the loss tangent. Okay, my sigma is equals to 3.65. Okay, so this one you can replace it with epsilon naught multiplied with 8. Okay, so I get 3.65 for my sigma, and this thing I put it here. Okay, this is omega. Okay, all thing I plug in. Okay, and I get my intrinsic impedance equals to 177.6, and the angle is 13.5. And next one is the velocity. Okay, so the velocity you can calculate by using these equations. Okay, and this is your omega, and this is the calculated beta, and you can get this one. This one is the speed. Okay, and next one is to calculate the H. Okay, because we want to define the equation for our H, magnetic field. First of all, we calculate its magnitude. Okay, based on this relationship. Okay, so this is the magnitude of E, and this is the intrinsic impedance that we calculate just now. So we get this one. And if according to the questions, so we check back the direction, everything. Okay, the electric field is propagated in the x directions, while the wave, the plane wave, is propagated in the positive z directions. Okay, so we consider this one. Okay, So the direction of my H will be in the Y directions. So here, just stack your things here. Okay, and then we put it here. And then this is the sine. And this is the beta. And this is the Y. Sorry, I missed this one. I missed this term. I should insert this term here. Okay. Okay, so I include it here. The angle. Okay, the angle of the H here. I should insert it here. Okay.